This is a heavily requested guide on how I add my motorized eye blinks to my masks. So here's how I did the electronics on this, in part 1. This is a list of materials that I used to assemble the electronic circuit. Basically, there's only a few different parts. I need a USB cable, which has a positive and a negative wire. You don't necessarily need a data cable. I have an on and off switch that I can use to turn the battery on and off. And the most important pieces is 2 micro servos. These are 9-gram motors. You can use any type of micro servo. Make sure you get the 180 degrees positionable ones and not the continuous rotation ones. The micro servos get a bag of little parts that you can use to assemble your machinery. We'll be using some parts. As a battery, I use a USB power bank. This will power the motors and the Arduino Nano that we'll be using. I already installed it in this mask, but this is a USB cable, an Arduino Nano and the on-off switch. This is specifically an Arduino Nano Every. They're a little bit cheaper, but more powerful and just as useful as a regular Nano. For this, I connect the USB cable, the positive and the negative wire to the Arduino Nano. The positive wire goes to the 5V port on the Arduino Nano, and the negative wire goes to the ground port on the Arduino Nano. I get these boards from Adafruit. They're about $12 to $15 each. Now there's an overview of the motor placement in my masks, which you will need to figure out for each mask that you're making. For my masks, I already designed the frame for it, but you can just glue or screw the motors into your frame wherever you like. For this mask, I use 1 motor for each eye. This is because the eyelids are slightly angled, so I can't use 1 motor for both eyes. I decided to place them on the inner corner of the eyelid because it was going to be more convenient angled that way. And I still had space to place both motors next to each other, without impairing my vision or the eyes. Now for these type of projects I do need to solder everything by hand. So I have my soldering station and I have some standard soldering equipment such as heat shrink. This will package up all the raw connections and avoids them from getting shorted or disconnected. Then I have my wire stripper as well. It makes it a lot easier to strip off the ends of the wires to solder them together. The micro motors come with a little connector, but I don't use these. I strip off the wires instead. They're a little bit too long and the connectors need to be fastened permanently anyway. Once I've cut the wires, I pry them apart so I can strip apart the ends with my wire stripper. Now to clarify, the ground wire is the brown wire, the red wire is the positive wire, and the yellow wire is the data wire. This can be different for some motors, but generally the dark wire is always the negative and the red wire or white wire is always the positive. And whichever color is left, which is usually yellow, orangey or green, is the data wire. The wires on both of my motors are stripped and separated. Now I can connect my ground wires and my positive wires together, because they will share the same power source anyway. I twist them and then I solder them together so that it's gonna be easier to connect later. Now I want to connect my motors to the power supply and the Arduino Nano, which will tell the motors what to do and at what time they need to move. The Arduino Nano has a bunch of different markings where you can solder connections to. I'll be using the digital pins, which is annotated with a D on the board. You can use whichever digital pin you want, usually it's between 2 and 12. I used the digital pins 10 and 11 because I was going to connect my motors on that side anyway. First I'm connecting my motors to the power supply. It's sharing the same 5V port as the Arduino Nano, so I'm just connecting it there. But you can also split up the wires in a fork if that's what you like. The power will not be flowing through the board as it will be connected directly to the power supply. It will instead be sharing the power source. Then I'm also connecting the data wire. Each motor gets its own data pin. So one motor gets this yellow wire connected to digital pin 10 and the other motor gets the connection soldered to digital pin 11. And this is how the final assembly looks like. You can use resistors to filter the data connection if you'd like, but I've never really had issues with it, so I didn't do that. And you can also solder a small capacitor between the ground and the 5V power source if you want to filter out that as well. But it's also not something I use on the regular. Now it's time to assemble the frame. The servo motors, every servo motor comes with a little bag of little parts that you can use to assemble your frame. I use a couple of these servo horns, as they're called, and a couple of the tiny screws in the packaging. Sometimes they also come with rubber mounts, which is useful to reduce vibrations. I've stuck a couple of the small servo horns of my motors to see and test out the motors. Now the Arduino Nano board is without programming still, so we're going to upload some programming to it to test the motors and our circuit. I'm sticking in a micro USB cable and connect it to my computer. Now it's time for programming. I used the Arduino app and used one of the example codes for the servo motors. This is called the sweep. This is just an example and you can use it to test your servo motors to make sure that everything's wired correctly. I'll be showing you how I modified this example code to suit my blinking mask. First, we need to change some things about the standard servo sign-up because we use two motors, so we're going to create two servos, servo 1 and servo 2. I'm just going to copy paste it and change the names so it suits my application. Then the example code also uses a variable position to use in their example. I'm going to leave it for now, we'll come back to this later. Then the standard setup code. This will tell the servo that it's connected to the board and which digital pin it uses to communicate with the servo motor. We'll need two lines for this because we have two motors, each on different digital pins. So one was attached to my digital pin 10 and one was attached to my digital pin 11. So I'm going to write that down and use the appropriate servo motor names that I assigned in the previous section. While I'm doing that, I'm also changing all the names that I modified in the rest of the sections as well. Now the example code starts with this for loop, which means that for each change that it makes, it moves up 1 degree. This results in a fairly slow movement, so we're going to delete that as we don't need it. We're just going to tell the motors to move to one position at the fastest speed as they can. Now before the motor moves again, we need to add a delay so it doesn't immediately try to move back to position before. So we're going to use this delay and make it a little bit longer to make sure that the eyes are closed for sufficient amount of time for the motor to reach the closed position. 150 milliseconds is plenty. Now this variable number here tells the motor to what position to move, but I'm going to be working in degrees directly. It makes it a little bit easier in my opinion. I'm going to tell both motors to reach 100 degrees angle. Now the regular servo motors can move between 0 degrees and 180 degrees. So by setting the start position of the eye to 100 degrees, you have plenty of room to tweak in one direction or the other direction. Now I have to add the second motor as well, so I'm simply copying and writing down the same line, only with its name 2 for servo 2. Now after the delay, we're going to add the second movement, because the motors will move between two positions, open and closed. I'm just going to add 50 degrees right now and see how that turns out after I test it. So servo 1 will get 150 degrees as a position. I'm going to copy the second line, add my servo 2, and instead of 150 degrees, it goes to 50 degrees. This is because the servo is of course on the other side of the mask, where it is rotated and basically a mirrored version. And the movement is inverted. It actually rotates clockwise instead of anti-clockwise, for example. Now these will be the positions for opening the eyes. And because I want the eyes to open and go to their stop positions when I turn on everything, I'm also putting it in my setup. This will tell the servos to go to their open eye position as soon as everything's turned on. Currently, the delay time between opening and closing the eye and then repeating everything is exactly the same, only a fraction of a second. So we want to delay when the mask blinks again with an interval between that. Usually you blink every few seconds, so we're going to add that between the loop. Now I added 6000 as a test number here. That means 6000 milliseconds, which is 6 seconds between blinks. This is how long it will tell the program to repeat the loop of opening and closing the eyes. Now ideally we want to change this up every time the eyes blink, because blinking everything at a standard 6-second interval seems a little bit robotic. So we want to make this a random number. We're going to use the variable number from the example and change it into our random number for the delay. And now we have to find a way to generate a random number. So I'm going to Google if Arduino has a way to generate a random number. And they do already have a standard random number generator that you can add into your code. So I'm going to scroll down to an example and see how it works. We want a random interval from about 1 to 6 seconds, so we're going to pick a random number between 1 and 6 seconds. I'm going to add it in my code. Because we want this random number to change every time that the eye blink is used, I'm going to put it in my loop. So every time the application loops through the program, a new number is chosen. I'm going to name this number random delay because that's how my integer variable is called. And I'm going to add the numbers 1500 and 6000. This is 1.5 seconds and 6 seconds in milliseconds. Now I'm going to click on verify to see if my programming is correct. It does tell me I have a mistake in there. It's because I did the wrong character here. And when I run verify again, it works. So I'm going to pick my board in the menu and upload it to my board. Then select the USB port that your Arduino Nano is connected to. If you then can't find out which one it is, just unplug and plug it in to see the difference. Then it's time to upload. Once the programming is uploaded to the board, it should immediately start working, even if your board is still connected by only a USB port. To unlock the full motors, you do have to hook up your USB power bank battery completely, because the USB cord doesn't always provide enough power for the motors. Now I can remove and add my horns in the right angle, because it will start at the same angle every time it opens up. Now that my servo motors are working, I'm going to assemble my frame. I 3D printed this frame and designed it to fit my masks, but you can also make it from all sorts of different materials, such as iron wire, plastic, thermoplastic, EVA foam, cardboard, whichever you like. I'm going to take advantage of all the little screws and pieces that I get included with my servo motors and add them to my frame. Now once I have some form of an eyelid shape assembled, I'm going to plug it into my motor and see what it does. It's time to add the power bank and turn it on. As you can see here, I accidentally put it on the wrong side on the wrong motor. Here we go, now it rotates the right way. Now the idea is to add this framework into the mask. I gotta position it at the right angle and make sure that the motor is fastened inside the mask. Here is a view from inside the mask. Now to fasten the motors inside the mask, I already made a frame that fits my motors perfectly, and it can be positioned in the mask at the right angle. Of course, you can have other ways to fasten your motors with glue or screws yourself. Now my eyelids are slotted into a little frame on the other side as well. This will make sure that the eyelids do not get displaced, and it also provides a mount for the eyes that I want to add in later. Here's how the frame looks like before it is glued into the mask. As you can see, the motor is on one side and the anchor on the other side. Now it's time to position my frame inside the mask entirely. This is crucial to see what kind of angle I want the eyelid at. And I'm going to fasten it in place with a screw first, before I'm going to add any glue. This will allow me to reposition and change anything before I start gluing things permanently. Now I'm going to turn it back on and see if I need to do any adjustments. As you can see here, the eyelid is drooping fairly low. So I'm going to just move the eyelid up a little bit by removing it from the motor and then adding it at a different angle back again. So I'm going to remove the eyelid and the motor from the frame again and then position it up a little bit. After I'm happy with the positioning, I'm adding both motors to the mask. Once both motors are positioned the way I want them, I'm going to mix up some 2-part epoxy glue to fasten everything permanently. My epoxy glue has hardened overnight, so everything's now in place to be used. I'm going to plug in my power bank again and test my eye blink. Now my frame is also suitable to screw in some eyeballs, so I'm going to add those and see how much it fits my eyelids first. These are little 30mm acrylic half balls that you can get from like the transparent Christmas balls that I use for crafting. I'm testing and dyeing them black to see if I can make them see-through, but also black looking. These are just tests for now. Now I already designed a little area where I can screw in my eyeballs using the little lip that's attached to all transparent half balls. There's quite a lot of space between the eyelids and the eyeballs, so I'm going to have to adjust that. I'm going to use my lighter to heat up the frame a little bit so I can bend the eyeballs in place and make them fit as close to the eyelids as possible without interfering with my eye blink mechanism. I'm just going to hold the eyeball in place while the plastic cools down and hardens up again. And that's the mechanism done. As you can see, there's quite a lot of space still remaining. All this space is really important for the eyelids to be able to fold, and also for you to be able to see. As you can see, there's lots of space under the eyeballs where I'll be able to see through. In the next step, I will show you how to add realistic skin or fur to cover up the eyelids. This will be in part 2 of this video.